Hello, this is question 6 in the 2015 MAT. So the world is divided into two species, vampires and werewolves. Vampires always tell the truth when talking about a vampire, but always lie when talking about a werewolf. Werewolves always tell the truth when talking about a werewolf, but always lie when talking about a vampire. Okay, note that this does not imply that creatures necessarily lie when speaking to creatures of the other species. Okay, right, so you could talk to a werewolf about a vampire if you were a vampire and still tell the truth. Okay. Note also that Zachariah is a vampire is a statement about Zachariah rather than necessarily about a vampire. So he may or may not be. Wow, okay. So they're certainly putting a lot of possibilities into these statements. These facts are well known to both sides. Yeah, well, good for them. The creatures can tell instinctively which species an individual belongs to. In your answers to the questions below, you may abbreviate vampire and werewolf to V and W respectively. Well, we'll probably do that anyway. Right, so A says B is a werewolf. Explain why A must be a werewolf, but we can tell nothing about B. Right, let's go into classic if then else strategy on this one, as we always do, or nearly always do in question 6. So they've made a statement. So if A is W, then, so that means they're a werewolf talking about someone else. Right, okay, right, we're going to have to split this again. So if B is W, so let's go both, then A is telling the truth. So A tells truth. Then that means we've got a werewolf saying that a werewolf is a werewolf. So that is possible. If B is a vampire, then what have we got? A is lying because they're a werewolf talking about a vampire, so they won't be telling the truth. So that is also consistent. Right, if A, so that fits with the answer that A is a werewolf, but we don't know about B. Now we do the other one then. So if A is V, then, and then we've got our other two options. So if B is W, then A is lying because they're talking about a werewolf when they're a vampire. So they would have to be lying by saying that B is a werewolf when B is a werewolf. So that doesn't work. If B is V, then A is telling the truth. That is telling truth, which is also a contradiction. So there we go. We've laid it out. Part 2. C says that D says E is a V. Right. E is a vampire. What can we infer about any of the three from this statement? Right. So we've got C saying what D has said about someone else. Now this sub bit D says about E, we've dealt with that in the previous part. But what is, so C is talking about D, not about E. So what we care about is whether C and D are the same or not. So let's go with that then. So if C is equal to D, then that means that C is telling the truth. Okay. So what does that mean? That means that C is telling the truth that D has said that E is a vampire. Right, okay, so, right, I'm just trying to follow this through. This has already got tricky. So D has said that, and from the first part, we know that if D has said that about E, then D must be a vampire. Okay, we don't know what E is. So, right, therefore, D is a vampire. So that's from part I. So therefore, oh well, and before we do that one, and we don't know about, okay, let's say E could be V or W. Therefore, C is a vampire. Okay, so that's a possibility. Then we've got if C is not equal to D, then what's happening? That means that C is lying. So Dieter hasn't said that. Well, we don't know anything then. I mean, we don't even know if Dieter said anything. If C is lying, we get nowhere. Therefore, we know nothing. So what is that? What can we infer about any of the three from this statement? Well, we haven't actually inferred anything really, have we? I mean, we don't know. Anything could be going on still. So we've got nothing definite. I mean, they could be the same, in which case they're both vampires. Oh well, we know they're both. We know they're not both werewolves. So that's something, isn't it? Then the only definite is that C and D are not both werewolves. That's all we can say, I think, out of this, because if they're different to each other, then anything could be going on. If they're the same, then they both have to be vampires. So that's about the only definite thing we've got out of all of that. Right, that was pretty tough. Part 3, suppose n creatures, n greater than or equal to 2, so it's not just one person, sitting around a circular table. Each tells their right-hand neighbour, you lie about your right-hand neighbour. What can we infer about n? What can we infer about the arrangement of creatures around the table? Right, let's take some people in a row then. Well, we're already, well, I'll just do A's and B's and things like that. So say we've got A, B, C, D, E. Let's just put 6 of them down for now. Each tells their right-hand neighbour, you lie about your right-hand neighbour. Right, so so we've got to start off, right, so let's have if A equals B. So if A and B are the same, then it's true what they're saying. So it's true that they lie about their right-hand neighbour, which means that therefore C is not equal to B, or A for that matter. So what does that mean? Then can we go any further than that? Just wondering what we could have then. So if say we had V, that would be a W, or we'd have WWV. So, well, actually, let's go into the next bit then of saying, well, if A is not equal to B, because that would be the same as B not equal to C, I suppose, then it's a lie, which means they are telling the truth. No, that they would tell the truth about their right-hand neighbour. So that would mean that, so A, B, that means that B would be equal to C. So in this case then, so if we add a VW here, that means that would have to be a W, that would have to be a V, which means that this would then have to be, oh, we're going in loops again. Right, so we're doing them in pairs next to each other. So we've got that. What can we infer about the arrangement of creatures around the table? Right, so they're going in that sequence. They got pairs next to each other. And we have to have then at least 4 of them on the table. So yes, so n must be a multiple of 4. And creatures arranged in blocks of what we got, VVWW or WWVV. I mean, it's the same thing really, but depends if you're going clockwise or anti-clockwise around the table. So yeah, that'd be it, wouldn't it? Actually, does it matter if you're going clockwise or clockwise? Anti-clockwise? Well, it depends where you start, doesn't it? But we're going in those blocks anyway. So yeah, it doesn't really matter actually, does it? Because if you had W, W, V, V, yeah, it's all the same. We're still going, it doesn't matter which way we're going round, so we don't need both of those things. Okay, so that's the third part. And And right, I'm going to need a new sheet to carry on with this. Okay, last part then. Consider a similar situation to that in part 3, possibly for a different value of n, except that now each tells their right-hand neighbour, your right-hand neighbour lies about their right-hand neighbour. Again, what can we infer about n and the arrangement of creatures around the table? Right, let's set up a bit of a table then. So A, B, C, D, E, F, G, H. Let's go up to H. Let's have 8 of them for starters. Right, we got a lot of permutations here, and they're talking about 2 along. So this would be A talking to B about C. So say A was a vampire, or maybe it would be a werewolf. So let's leave some space there. So if A is, this time we're caring about C, if they're the same, then what they're saying to B is true. So if A is equal to C, that means we've got that and that, which means we've got that. Well, we don't really need to do both because these are going to be completely interchangeable. Doesn't make any difference, does it? Because V and W we can just swap for each other, but still I've written it out now, so I'll just leave it there. They're telling B, your right-hand neighbour lies about their right-hand neighbour, so that would be true, so that must be different. That means that C is not equal to D. Okay, if they're different to each other, A is not equal to C, then we've got a lie, which would mean that C would be equal to D. So say we had then VW, I'm still going to put in all these permutations, so that would be WV, and that would be WV. Okay, so, well, we could do the same thing here then for B, couldn't we? We could do the same thing for B. Maybe I could reuse these lines in between, which are just duplicates of swapping over one for the other, because I don't really need it. Let's change to blue then. So if B equals D, so we'd then be saying, yeah, let's not use this line so much here. Let's make that a, if B is equal to D, so that would be a W, or here it would be a different one. So here we'd be saying V and V and W, like we worked out from the first bit, and then we'll say that one is different. So we've got B is equal to D, or B is not equal to D. Right, that's good. Then we'd be saying that if they're equal to D, then that's true, which means that E is not equal to D. So we would then be making that a V, and here it would be a lie saying that E is equal to D. So we get a W. We could do a similar thing here. So let's make that a V again, and let's make that a, what was I changing? That would be a, these things are then different to each other. Is that right? So that would be a W. Yep, they're different, which means that would then be a W. So we're saying we've got a W or we've got a V. Okay. So in this case, we'd have B is equal to D, which means that would be different, or they're the same. So, right, we seem to have blocks here. And then, so if those two are different, then we get the same. If they're the same, then we get different. And then again, if they're different, we get the same. If they're different, we get the same. Yeah, so, okay, it's definite pattern here. So we're getting that. If they're the same, they're different. If they're different, then they're the same. If they're the same, then they're different. Okay, right. So we've got this pattern. So we've got 2 different patterns by the look of it here, I think. Let's just clean these up a little bit. So we've got V, W, V, W, V, W, V. They're just swapping. Or we've got V, 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 W, 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 V. We got V, W, 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 V, V, V. These are going in blocks of 6, aren't they? V, V, W, 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 V, V. So it's all based on these things. That's giving us our structure of what to do. We're being able to get the next one in the sequence by looking how these two that are 2 apart are. If they're the same, then the next one's different. If they're different, then the next one's the same. So we build that up. So what do we have to say? What can we infer about n and the arrangement of creatures around the table? So we've got two options. So we've got either, what ones have we got? So this first one is just going VW, VW. We've got n is a multiple of 2. And we've got VW pairs. Or we've got n is a multiple of 6. And we've got VWWW blocks. Right, okay, that was a slog of a question, but the same approach as we take in these things is always if then else and all that sort of thing. So yeah, maybe not quite as fun as some of the other question 6s, but I suppose you get there in the end.